Welcome back to the KAASM channel. We have a special guest for you guys today, and I can't wait for you to meet him. Hey Sean, so who's our special guest today?
We're pretty fortunate. Calvin's in town from Vertech, which subsequently is our partner of the year. They won the KAASM Cup. So Calvin's here, looking forward to spending a couple of days with him. He's a stud programmer. Looking forward to see what we're going to work on today, or actually in the next couple of days. But we're going to turn out a couple tutorials and get to see what Vertech brings to the table as one of our solution partners, one of our Siemens Solution Partners.
Okay, really cool. Let's go talk to Calvin from Vertech. Hey Calvin, thanks for visiting us here at KAASM.
It's always great to be here with you guys.
So we appreciate you sharing your knowledge with us. What do you have for us today?
Today we're going to go over the concept of unit testing inside of WinCC OA.
Okay, unit testing, what is that?
Unit testing is the concept of testing an individual unit of your code so that the whole process flows a little better and catches the bugs earlier.
Okay, is that like debugging?
In a way it is, but the point of unit testing is to try to catch the bugs before we need to get to the debugging stage of the development lifecycle.
Okay, really cool. Let's go check it out.
First thing we're going to do is we're just going to set up a basic project. I'm going to call mine unit tests. In a real world system, you're going to just attach this to a project that's already created. But for this demo, I'll show you, just do it this way. There's nothing special about the project, just a standard project without a root password, which is terrible security practice, but for the demo,
Yeah.
it's okay.
So it's just creating the project directory and file structure of the project that you're going to be working in, right?
Yep.
So you're going to fire it up.
Yep, I'm going to start it up, and I have some scripts written already and control and other libraries created that I'm going to bring in, and I'll explain what each of them is as I bring them in.
Mm-hmm.
So first thing I'm going to do is I'm just going to create a new library. I use libraries to actually hold my classes that I'm going to use, utilizing the object-oriented nature of OA. So I'm creating one, and it's called just helper. And during my actual production projects, I do use a script called helper quite a bit.
Okay, so this is the one that, excuse me.
So here I'm just copying it from the script that I had written on my personal machine. I'll bring it in. And so all you see is it's just a simple class with a single function inside of it called subtract. And all that subtract function does is take x minus y and returns it as an int. So here I'm just pasting in that simple script into actual WinCC OA so that we can utilize it.
And is this the helper, the CTL script?
Yep, this is that CTL script that I created. Next thing I'm going to do is, again, I have some scripts that I've written. I'm going to create a new panel. Just call it test or just open up this panel, and inside the initialize script, I'm going to take those scripts that I wrote earlier and put them in. I wrote them earlier just because it's easier and no one wants to watch me type out code on a video.
Right, and you're using the panel to, this is an easy way to run an initialize script that's just going to launch it immediately when you put it into like a quick test mode, right?
Yep. Yeah, you could set this up on more of an automated standard by putting it into a control lib and have it run in the PMON, but for our purposes, this is a really easy way to do it. So this will give you kind of a quick overview of what's happening inside of it. Two important things to notice inside of this script are the two uses statement at the top. The first one is the control OA unit test, or a unit lib. This is what's actually needed to run the unit tests and to give them access to the functionality. The second uses statement is that helper class that I created earlier. This allows us to import it into this panel. Directly below that, I'm instantiating that helper class by saying helper is a help. And now we have access to the subtract function.
Cool.
Next thing I need to do is I'm just going to create a simple data point inside of my para. And I'm just doing this for a little demo that I'm going to give later. And here's me forgetting what I named it, so I went back into my script to get it. All this data point is it's a simple int, and I'm going to give it a value of 5. The 5 has no meaning except for what we're going to run the test against later.
And this is what you were saying, like that's the absolute that you're going to say, hey, if it's not 5, then you need to be failing.
Yes.
Got it.
So go back into my scripts, and inside of it you see that I've just got a bunch of tests and 3 small simple functions that are part of it. One thing that I forgot to mention earlier when we created this class is the importance of some of the naming conventions inside of your external classes. In this one particularly, the public keyword is very important because that's what allows you to access that function outside of the class itself. Natively, functions are private inside of WinCC OA, so you have to declare them public to make them available. So if I were to remove this public word here, I would not be able to access it inside of the script that we were creating earlier. So this is now a private function. And as I put public back into it, it's now accessible for us to use inside of other scripts or panels.
It's good to know.
Mm-hmm. So what I've done is I just went through and I kind of formatted my code just to make it look a little nicer and easier to read. Sloppy code is very nitpicky of me to not like, so I went through and changed it. What you see in here is we have a bunch of OA unit assert statements. And what assert basically is it's saying this function should return something, and I'm saying what the return should be. So the first parameter is the name of the unit test. And the first unit test doesn't have a very good naming convention, but it's the demo one that they give you inside of the lib, so I decided to put it in. The second parameter inside that assert equal function is the function that you're trying to call itself. So inside we're using the string position function or string pos, and we're saying looking for where inside that string the letter E is, and it's at position 4, and you're probably thinking to yourself, hey, no it's not, it's at position 5, but inside of OA, strings have a zero-based array, so it is at position 4. And then the third parameter of the assert equal function is me saying I expect it to be 4, so I'm asserting that 4 will equal 4.
So you're also saying that 0 is a number, right? So A is 0, B is 1, C is 2.
Yes.
And so in this string, E is actually 4.
Yes.
Okay.
So this next assert function that we're using is should add 2 numbers together. That's the name of the unit test itself, and all it's doing is it's calling the add function down on the bottom that accepts 2 integers, adds them together, and returns another integer. So I'm saying 3 plus 3 will equal 6. And this is true, so this unit test will pass. This next one that we're looking at is an interesting case, and the reason this is interesting is because we shouldn't expect 3.5 and 3 to equal 6. But because of the way that WinCC OA interprets numbers sometimes, 3.5 will be casted down to an int. So the function ends up returning 3 plus 3 equals 6. This is important to remember because of the way that you have to write your code. And sometimes you may get data types that are not what you expect. So being very careful on how you assign data types in your functions is very important. So this next function is using the external class that we created. So I'm basically saying help.subtract 6 and 3. So inside of the help class that we created earlier, we have the subtract function. It takes 6 minus 3, and we're asserting that 6 minus 3 will equal 3, which of course we all know will be true. Okay, these next two unit tests are very interesting because you look at them and they're very similar. They both use a function I created called addFloat, which accepts two float numbers and returns a float value as its output. So the first one I'm saying should add two floats together, takes 3.5 and adds another 3.5 and returns a 7.0. This one will succeed. And the reason it succeeds is because 7.0 is a float value, whereas on the next unit test that I called should add two floats together fail, which is a terrible naming convention, but showing for example, I'm saying 3.5 add 3.5 equals 7, which technically is true, but because 7 is an integer and not typed as a float value, this test will fail. So again, this shows the importance of knowing what kind of data types you're working with at all times and making sure that correct data types are utilized throughout your application. And you'll see the results of this when we actually run the tests. So this next test is just showing the other values of the assert library. So it's using an assert not equal, and we're saying that we're adding two numbers together, 3.5 and 3.5, and I'm saying that it will return 7.1, which of course is not true, but this test will pass because we're saying that those two numbers will not equal that. And then this final one that we're looking at is kind of again, a different thing that you could utilize a lot inside of your most applications, and I'm calling a dpget. But what I'm doing is that I'm extracting that dpget function to another function. And so I created a function called dpget integer, and it simply passes the tag path through to it. This is a really good programming practice because it allows you to unit test these individual functions of code. And all this is doing is it's passing through the tag path, and inside the function, we call a simple dpget, and that's that data point that we created earlier. And I'm saying it will equal 5, which we know is true because that's what we set the value to earlier. Again, this is a really good way to abstract your code and make it very unit testable for everything. So you could use this for all the different levels. So I'm just simply going to save my script and then make sure my log viewer is open, clear it out from before, and then I'm just going to run this panel.
It's going to trigger the initialize script.
Yep. The initialize script is going to fire, and here you can see the results of our tests. So the first sets of tests are all passed because we set them up to do so. This next one is a fail, and this is that data type error that I was explaining earlier. The cool thing about this is it will show you exactly what test it failed on, the line of code that it failed on, and the error that caused it. So this is an easy way if you have this set up to be automated to find where some of the errors occur in your logic.
This is great, just using the simple log viewer tool to get the feedback of your asserts.
Exactly. You can export these to external files, to like an external TXT file, but the log viewer works really well for this. But if you wanted to keep a record of all your unit tests happening at all times, sending it out to that external file would be useful.
Okay, great. This is useful. Yeah, thanks. We appreciate that.
Oh, no problem.
All right, Calvin, thanks for that. That was really informative. We do have a few questions for you. First, how is this useful to the end user?
The end user is really going to appreciate this because they're not going to have to worry about bugs in their system as much, which means it's good for the integrators as well, because we're not going to be receiving the calls at 2 a.m. saying that something is broken.
Okay, cool. But why wouldn't they use the native debugger in a way?
So the debugger is for catching bugs as they occur. The point of unit testing is to try to catch them before they occur. So the debugger is going to be like kind of a just-in-time approach versus a let's catch them before that type of thing happens.
Okay, really cool. Thank you, Calvin, very much. This was awesome. Hope to have you back again sometime for another tutorial.
All right, thanks everyone.
All right, thanks for watching. If you want to learn more about Vertech and what they do, please check out the link below in the description. And remember to subscribe to the KAASM channel and click that bell to stay notified of future updates. Thank you.